Hey everyone, let's take a look at number 5 in section 4.4. Fairly quick one. We're going to determine the intervals where the function f is concave up or down, and then find the points of inflection. And here's our function. Nice polynomial function, though the domain of this function is all real numbers. And we are simply needing the second derivative, right? Second derivative tells us where a function is concave up or concave down. Remember, function's concave up when its derivative is increasing, which means the second derivative is positive, and it's concave down when the derivative is decreasing, which means its second derivative must be negative. So that's what we're going to use to help. Finding the derivative should be no problem. By the power rule, we've got the derivative of 7x squared is 14x, and the derivative of x to the fourth is 4x cubed. Take the derivative of this to get the second derivative. Derivative of 14x is 4. Bring the 3 down, we get 12x. Subtracting 1 gives us 12x squared. Now, we typically want to say when is this derivative, or second derivative rather, going to be equal to 0, because that's where we might have points of inflection. But notice that the value of our second derivative is always going to be at least 14, because if I plug in any value of x and square it, the output is always non-negative. The smallest that 12x squared could be is 0. That's the smallest it can be. If it is 0, I get 14. So the second derivative can never be 0. If you try and solve this for 0, you would say 14 plus 12x squared is equal to 0. And we'll just set that up. You'll have 12x squared is equal to negative 14. There's a problem already. If I'm squaring some number here and multiplying by 12, I'm not going to get negative 14. If I divide by 12, I get x squared is negative, right? Negative 14 divided by a positive 12 is negative. 14 twelfths is the same as 7/6. Yeah, you can simplify it that way. But now if you say, well, let me just take the square root of both sides, you've got a problem, right? The square root of negative 7/6 is not a real number. So there's no solution in the real numbers for this equation. Bottom line, our second derivative is positive for all values of x. If I ask for a sign check in this case, this is what it looks like. There's no place where it's 0 or undefined. Simply then, the function f is concave up for all real numbers. It's never concave down. I believe Achieve wants you to use this symbol for the empty set. And f, of course, has no points of inflection. There's never a change in concavity. Okay, I hope this is helpful on this one.